log.d, log.e, whatever output from an application is going to go. So you access these logs using the LOGCAT utility. A lot of people have probably used that and just seen that typically you're going to see a big stream of data because there's an awful lot of chatty stuff that's going on the device at any particular point in time. So ability to read the system logs is actually gated by the read logs permission. The shell account is granted this permission so that when you have ADB debugging enabled, you can do ADB logcat from a host system that's tethered through a USB cable and see things. But you can kind of think of read logs as an alias for read everything, as we're gonna show here in a second. And it's worth noting that the documentation on the read logs permission actually recommends that that developers be careful about what they disclose in the system logs. So we put a client together, and this is an Android service that only requests read logs and internet. And as you guys have just seen in this room, internet is actually just to make it easier to write the POC here. David demonstrated that that's not really required. So the client downloads a set of policies from the server, and they're basically regular expressions that scrape the logs and feed interesting stuff back to the server component for analysis. So just to kind of flip through the structure of the client here quickly, we have a LOGCATDEVICE class that wraps basically the LOGCAT command and opens that channel, sets up line-oriented reader. We have a LOGMONITOR, which is kind of the core event loop here, going through processing that data, matching against the filter sets, and deciding what to actually deliver back to the back end. And this is all set up as a service so that it can run in the background so that we don't have to keep an activity up in order to actually do useful work. So the server is a Rails server. Basically supplies policy command and control and processes the device data. So we have per device policies, and it's the receiver for stuff that we're sending back to the back end. Provides an interface to explore the logs that we've collected, and in a couple of cases does some interesting extraction of particularly interesting bits of data and post-processing on that. So what do I mean by policies, and what are we actually doing with this stuff? Well, we basically decided to kind of do a survey of what kind of data we could find in the logs. Started with just a few random keywords, things like insert, update, delete. These are things that you're going to see in SQL statements, and that might be an interesting target, looking for stuff that's going through SQLite. Intent. That's a core concept in the system. Content, we have content providers that are throwing a lot of data around. HTTP, anything that's protocol related. And we also put together a couple of pieces of targeted data. So things like, first name, last name, a particular targeted made up phone number, things that might be pushing through applications. And we set up this initial set of expressions and started pushing data through channels that are commonly used, different applications, and then started to dig into what we found on the other side. So one of the first things that we tripped over with SQL keywords is that actually in 2.2 there's kind of a new series of log data that appeared in that actually appeared in the event log. And the event log, for the most part, at least in 2.1, doesn't seem to contain anything that makes a lot of sense when you're just kind of looking it over. But this data is a little bit more interesting. So there's apparently a hook in the SQLite driver that actually logs the first 64 characters of a sampling of queries that are run through that driver. And the sample rate is based on query execution time. So we don't see every single query, but we do see some subset of queries accessing databases really all over the system. Now, we didn't find any major smoking guns here, but it's something that developers should really be aware of. Don't put sensitive data directly into your SQL statements. Parameterize them because they may show up in places that you didn't intend. There's a similar hook that does the same thing for content providers. And here's an example, not terribly interesting, but some data that actually is disclosed. For instance, when you're actually doing a phone number lookup in the main contact application. But like I said, we have this series of permissions that gate access to different pieces of system data, and a lot of these things actually end up turning up in the system logs. So there's actually a get tasks permission that allows you to retrieve a list of the most recently accessed activities in the system. As it turns out, those activities, or when intents fire to launch those activities, those are also logged. So if you're just scanning the system logs, you can put that data together and construct the same thing. There's actually there's a dump permission that gates access to crash dump data about applications, and lo and behold, all of that data also happens to be in the log, so you can pull it up too. But there's some more interesting things. So there's a permission read history bookmarks, which actually gates access to browser history on the device. And as we can see here, when the browser activity is launched, you actually get some log data about the URL that was accessed. But furthermore, there are other applications that are on some devices, and a lot of this stuff is a bit variable between the different OEM system images, that may actually log quite a bit more data. So here we can see an example of a bookmark activity which takes screenshots of pages that are accessed and keeps them in the system in the browser UI. Of a Google search for something embarrassing. And also, by the way, you can see things like authentication token data here too. And Kevin and John from Lookout talked about a pretty serious authentication disclosure vulnerability that was found out there. And this is another channel where the same kind of thing could happen. So when you're developing backends for mobile applications, be aware of the data that you're sending out may end up where you didn't expect it. Another interesting thing, there's a permission that gates read SMS, and as it turns out, when the debug levels are turned up, which they are on some system images out there, then when you send SMS, we see not only the content but also the recipient logged. We also found an interesting application out there that had read SMS permissions that was just turning around and logging the content of all received SMS to the system log. So here we can pretty much scrape out both sent and received conversations only with the read logs permission. There are also components on one system that log the contact data that goes through all the fields of the activity in the contact manager. And so this actually pulls out these pieces of data and logs it here along with the label of the field that was accessing the data. And so we can reconstruct your contact database for any contact that you access. And perhaps most interesting to us in some sense, read logs can be an alias for access course location. So on GSM devices, up until 2.1, and this has been fixed in 2.2, by the way, the network location provider would actually log the LAC and the cell ID of the tower that your device hops to when it connects to a new tower. That in and of itself doesn't tell us anything interesting, but we'll get to that in just a second. The CDMA the CDMA sets actually log the full latitude and longitude of the tower in many cases. There's a very prominent clock and weather application that runs on a lot of handsets out there that also logs the equivalent of course location data to the system logs on a periodic basis every few minutes. And I mentioned the radio logs before. The radio logs, as it turns out, also disclose the cell ID and the LAC in addition to the MNC and MCC, so we can actually pin down operator and location and tower identity. So what do we do with that? Well, we take that and we can use a database like the Ericsson cell ID database, and we can actually turn that into a latitude and longitude for the tower that you're talking to, and that gets us equivalent to course location. But we can actually do better. Because as it turns out, the full find location data, which should be gated by access find location, shows up in a lot of places. That same widget that I was talking about logging course location data actually happens to log the GPS coordinates as well. The underlying GPS infrastructure on several devices that we looked at is logging the latitude and longitude out of the GPS location provider, and the underlying libraries are as well. Now, one thing to point out is that this only happens when you're actually actively interacting with the GPS. So it's not like you're getting constant, foot by foot movement, but it is enough to put together to tell a pretty good story. Like a story about three guys who started at their office in South of Market in San Francisco, walked down to the corner, caught a cab, headed down the 101 to San Francisco International Airport, where they checked in the terminal and boarded a Virgin flight, and flew Southwest down to Las Vegas, arriving at McCarran, and you can actually see the, you can see us touching base here in the terminal, going out to pick up some bags, taking a cab across town to Caesar's Palace, where we checked in at the front desk, went up to our room, dropped our stuff off, went over to speakers registration for Black Hat, went back down to our room to work on slides until 4 o'clock in the morning, until we left a few days later and took another cab across town to the Riviera to check in for DEFCON 18. So now that I've talked a little bit about this, I'm going to turn it over to Anthony, and he's going to talk a little bit about the ultimate permission.
Thanks, Tim. So we're going to rush through this a little faster because we're running out of time here. So essentially we know that Android phones aren't necessarily this perfect utopia of open source hardware that we can all do whatever we want with it. A lot of phones are shipping locked right now, and a lot of people are forming entire communities around this idea of being able to root their phones and be able to do a lot of modification. I'm just curious, how many people in this room have an Android phone? Okay. How many people in this room with an Android phone have rooted it? Okay. How many people that have rooted a phone have not issued an update or a patch because they didn't want to lose that method of being able to root their phone? Okay, that's good. That's good. So what are some of the ways that we're able to get root on these phones? Some of the methods that people are using are looking at older Linux kernel bugs. There have been a lot in the past few years. So basically you can look up on lists like Full Disclosure and see what kind of stuff is available. This is a list of all the various kernel releases for each major version of Android, with 3.0 coming out in the future, which should be using 2633 or 2644. Also, you can take a look at older unpatched libraries and binaries that are shipping on the system. I know one of the first Android vulnerabilities that were found were back when it was still just an SDK before there's actually any hardware. It was in some of the imaging libraries, was an overflow that Alfredo Ortega on the core team found. But pretty much a lot of the ways that we've been looking for vulnerabilities on Linux apply to Android since it's running on Linux. So let's take a look at this specific case study. This is a vulnerability that came out recently that was very similar to the libudev vuln CVE 2009-1185 that was discovered by Sebastian Kramer. I would like to point out that we did incorrectly state at Black Hat that this vulnerability was in fact CVE 2009-1185. but Android itself does not use libudev, but they, in their implementation of handling events, proceeded to recreate the exact same bug, and Sebastian took his exploit that he wrote originally for that and was able to port that to run on Android. Upon